1972, a desert test range in the American Southwest. A hulking, blunt-nosed aircraft sits on the ramp under a hard white sun. It is slow. Its wings are straight, like something out of the 1940s. Its two engines are bolted to pylons above the rear fuselage in a way that looks like an afterthought, as if someone had forgotten them and stuck them on at the last minute. Its nose gear is offset to one side. Its landing gear does not fully retract. Its top speed is roughly 420 miles per hour, slower than some propeller-driven fighters of the Second World War. Fighter pilots who saw it laughed. It had no afterburner. It had no radar worth the name. It could not go supersonic, could not dogfight, could not intercept anything. In an era when the United States Air Force was buying Mach 2 interceptors with swing wings and sophisticated missiles, this thing looked like a mistake. Officers called it ugly. Crews would eventually call it the Warthog, and the name stuck because it fit. And inside its fuselage, wrapped around the pilot's seat like a coffin turned inside out, was a structure that had no equivalent anywhere in Western military aviation. A tub of titanium armor plate, weighing roughly 2,100 pounds, enclosing the cockpit on all sides and underneath. Not a panel, not a plate behind the seat. A complete armored enclosure that the pilot climbed down into before every mission. Its designation was the A-10 Thunderbolt II, and it became one of the most survivable combat aircraft ever built. To understand why the A-10 existed, you have to understand what the United States learned in Vietnam. Close air support, the mission of putting explosives on enemy positions a few hundred meters from friendly troops, requires an aircraft to come low, come slow, and stay. Fast jets could not do it well. An F-4 Phantom, screaming past at 500 knots, gets one look at the target, and the pilot has seconds to identify friend from enemy. It burns fuel at a catastrophic rate at low altitude, meaning it cannot loiter over troops in contact. And when it is hit by ground fire, which at low altitude it will be, it tends to come apart. The Air Force needed something else. In the late 1960s, the service launched a program called AX, for Attack Experimental. The requirements read less like an aircraft specification and more like a list of grievances. Long loiter time over the battlefield, heavy weapons load, the ability to operate from short, rough forward airstrips, low cost, and above all, survivability, defined not as the ability to avoid being hit, but as the ability to be hit and keep flying. That last requirement was the one that shaped everything. Fairchild Republic, based on Long Island, won the fly-off against the Northrop YA-9A in 1972 and 1973. The A-10 reached operational squadrons in 1977. The design philosophy was inverted from almost every other combat aircraft of the era. Most aircraft are designed and then armed. The A-10 was armed and then designed around the weapon. The gun was the GAU-8 Avenger, a 30mm rotary cannon roughly the size and mass of a small car, and the airframe was arranged around it. That is why the nose landing gear sits off-center. The gun's firing barrel had to be on the aircraft's center line, so the wheel had to move. But the gun is the part everyone talks about. The part that kept pilots alive is the armor. The titanium bathtub is a welded enclosure of high-strength titanium alloy plate that surrounds the cockpit floor, sides, and the area forward of the instrument panel. It protects the pilot and portions of the flight control system. The United States Air Force states that the aircraft can survive direct hits from armor-piercing and high-explosive projectiles, up to 23 millimeters. The caliber of the Soviet anti-aircraft guns the A-10 was designed to fly into. Testing also addressed fragmentation from larger shells, on the order of 57mm bursts. The engineering logic was not glamorous. Titanium was chosen because it offers high strength at relatively low weight and resists corrosion. Rounds that would punch through the thin aluminum skin of a conventional fighter tend to shatter or deflect against a thick titanium wall. Just as importantly, When a surface-to-air missile or a large anti-aircraft shell detonates near the aircraft rather than striking it, the resulting cloud of high-velocity fragments is stopped by the enclosure rather than reaching the pilot. The bathtub is not magic. It is not rated to defeat a direct hit from every weapon on a modern battlefield. But that was never the claim. The claim was that the pilot survives the engagement and the aircraft gets home. Now, before we get into what actually happened when this design met real anti-aircraft fire, if you are enjoying this kind of deep dive into military engineering, hit subscribe. It costs nothing, takes a second, and helps this channel keep producing these stories. The armor was only one layer of a much larger philosophy. The A-10's designers worked from a principle that runs against instinct in aircraft design. Assume the aircraft will be hit, and build so that no single hit is fatal. The two engines are mounted high on the rear fuselage and spaced widely apart, so that a hit that destroys one is unlikely to destroy the other. The fuel tanks are self-sealing and filled with reticulated foam to suppress explosion. The flight controls are hydraulically powered with redundant systems, and behind those redundant hydraulics sits a purely mechanical backup called manual reversion, a system of cables, cranks, and pulleys that allows a pilot to fly the aircraft with no hydraulic power at all. Almost no other combat jet in the world has that. The twin tails mean that losing one vertical stabilizer does not necessarily mean losing control. Landing gear that only partly retracts sounds like a design in failure until you consider what happens during a gear-up landing on a damaged aircraft. Every one of these choices costs performance. Armor is weight. Redundancy is weight. Foam-filled tanks are weight. The A-10 is slow precisely because it is heavy with things designed to keep it alive. This is the trade nobody wanted to make in the 1970s. Every other program office in the Air Force was buying speed, altitude, and sensors. Speed and altitude are themselves forms of protection, and they are cheaper in weight than steel or titanium. The A-10 could not use either. Its mission was defined by proximity to friendly troops, which meant flying where the troops were, at the altitude where every machine gun on the battlefield could reach it. It could not outrun the threat, so it was built to absorb it. There is a second, quieter consequence of that philosophy. Aircraft designed to be repaired are aircraft designed to be simple. Damage that would require a factory rebuild on a complex airframe could be patched in the field on an A-10, and the fleet's maintenance record reflects that. An aircraft that comes home is only valuable if it can be made to fly again quickly, and the A-10 was built with that second half of the equation in mind. The proof arrived over Baghdad on April 7, 2003. Captain Kim Campbell, deployed with the 382nd Air Expeditionary Wing, was flying a close air support mission over the city with her flight lead, Lieutenant Colonel Richard Turner. They had been supporting ground forces and were leaving the target area when Campbell's aircraft was hit by enemy fire at the rear of the airframe. The result was immediate and catastrophic. She lost hydraulic pressure. The caution panel lit up. The jet rolled left and pointed toward the ground, toward central Baghdad, and stopped responding to her control inputs. She tried several procedures. None worked. Then she switched the aircraft into manual reversion, the mechanical backup of cables and cranks, and the A-10 responded. It began climbing away from the city. As she later described it, that was her last chance to recover the aircraft. The alternative was ejecting into central Baghdad during the invasion. She could not see the damage herself because it was behind her. Turner moved his aircraft into position to look. The rear fuselage, the horizontal stabilizer, the tail section, and the engine cowling had been hit. Sections of the hydraulic system were gone. The aircraft was riddled. Campbell flew it for roughly an hour, in manual reversion, back to Ahmad al-Jaber Air Base in Kuwait, and landed it. Manual reversion landings are not routine. An Air Force study of the system in the early 1980s described the pilot workload in that mode as exceptionally demanding, and noted that landing in manual reversion had been flagged as an unacceptable workload as early as 1973. Campbell knew that other pilots had attempted it, and that at least one had not survived. She landed anyway. The pilot walked away. Hers is the most famous case, but it is not isolated. During the 1991 Gulf War, A-10s returned to base with damage that would have destroyed most aircraft, including one that lost a substantial portion of a wing to a surface-to-air missile hit and still recovered. In a mid-1970s Fairchild Republic presentation on the A-10's survivability design, written by engineer Joseph Arrighi, the point is made bluntly. The aircraft was designed from its inception to a complete set of survivability requirements. It was not armored as an afterthought. Armor was the specification. One pilot account preserved by the Cradle of Aviation Museum describes an aircraft that took 17 major holes in the right side just below the cockpit. The titanium bathtub was chipped and gouged. The pilot was not scratched. 5 days later, the aircraft had been patched, given new control surfaces, and flown out. The comparisons are instructive. Fast jets are survivable by not being hit. They fly high, fly fast, use stealth, use standoff weapons, and rely on never entering the envelope of the guns below. That works until the mission requires being close to the ground for extended periods. The A-10 took the opposite position. It accepted that it would be shot at, accepted the hits, and paid for that acceptance in speed and elegance. That is why it looks the way it does. The aircraft has been declared obsolete repeatedly. The Air Force has tried to retire it more than once, arguing that modern air defenses make low, slow flight suicidal, and there is real substance to that argument. Modern surface-to-air missiles and radar-guided systems are not the same threat as a 23mm gun in 1975. The A-10's era is genuinely closing, and the fleet has been progressively retired. But the design idea outlived the debate. The lesson the A-10 taught was not that armor beats missiles. It was that survivability is a design requirement, not a bonus feature, and that it has to be written into the specification before the first line is drawn. 1972, a desert ramp under a hard white sun. A slow, ugly, straight-winged aircraft that fighter pilots laughed at. No afterburner, no supersonic dash, no elegance of any kind. Built around a gun, wrapped around a tub of titanium, engineered on the assumption that it would be hit and hit hard. It was hit, repeatedly, across 4 decades and several wars. And again, it came home with holes in it, and a pilot who walked away from the airplane. That is not glamour. That is not speed. That is the difference between an aircraft designed to avoid the battlefield and an aircraft designed to live in it.